Good morning, students. Myself, M.Hukkeri, HOD of Physics Department, SNPU College, Dharwad. So, in view of COVID-19, we are planning to have the online classes. Till it gets scheduled, we'll send you some videos and cover some topics. So, in this context, I deal with chapter 9, that is ray optics and optical instruments. The introduction part. Before we go for the introduction, you have studied ray optics and optical instruments in class 10th. So that is your apperceptive knowledge. You have to refresh yourself, and if you have a book, you can refer the 10th class book for this particular subject matter. In a ray optics and optical instruments, in introductory part, our eyes have the ability to detect visible light having a small wavelength range of 400 nanometer or 4000 angstrom unit for violet light to 750 nanometer or 7500 angstrom unit for red color. Our eyes cannot detect invisible radiations like gamma rays, X-rays, ultraviolet rays and infrared rays. So solely we'll be discussing on visible light in ray optics. Based on some properties of light, we discuss the working and construction and working of optical instruments. Light is a form of energy. It has an ability to do work. So as you know, the difference between the sources of energy and forms of energy. Energy neither being created nor being destroyed. So one form of energy can be converted into another form of energy. And all forms of energy have the ability to do work. Likewise, light has an ability to do work. For example, photosynthesis work is carried out in the presence of sunlight. Now, Crookes radiometer is a device. It consists of a wheel. When a light is made to fall on that wheel starts rotating. In other words, light rays exert mechanical pressure. Hence, light has the ability to do work. Light is an electromagnetic radiation. It travels with an enormous speed and always along a straight line in a given medium. So these are the two important things about the light. Namely, the first one is it travels with an enormous speed. Number two, and always travels along straight line in a given medium. So in a speed of light in a vacuum. Vacuum is an optical medium without comprising any matter. So number of experiments were conducted to determine the speed of light. Mainly the Michelson-Morley experiment, Euler-Roemer experiment, they have determined the speed of light in vacuum to the accuracy of C equals to 2.99792,458 meter per second. For all practical purposes or in practice, we approximately take it as 3 into 10 to the power of 8 meter per second. All radiations, whether visible or invisible, they travel with the same speed 3 into 10 to the power of 8 meter per second in vacuum. Wavelength of a light being very small, it appears to travel in a straight line. Sound waves, water waves, tsunami waves, they have the longer wavelength, whereas the wavelength of light is in angstrom units, though it has having a wave nature and having a shortest wavelength, light appears to travel in straight line. The path followed by the light between 2 points is called a ray of light. It is represented by a directed line segment AB. It gives the direction of propagation of light. The bundle of rays is called a beam of light. We have three types of beams of light: parallel beam of light, divergent beam of light, convergent beam of light. The various properties of light: rectilinear propagation of light, reflection of light, refraction of light, dispersion of light, interference of light, diffraction of light, polarization of light, photoelectric effect. So the first four properties of light can be explained on the basis of ray concept of light, assuming that light travels along straight line. The properties of light: interference of light, diffraction of light, polarization of light, photoelectric effect. Excluding the photoelectric effect, 5, 6, 7 properties are explained only on the basis of a wave nature of light. Whereas the eighth property of light, that is a photoelectric effect, can be explained on the basis of Max Planck's quantum theory of light, that is a particle nature of light. Optics. Optics is a branch of physics which deals with nature, sources of light, propagation of light, properties of light, and effects of light. This optics is further classified as ray optics, wave optics, and photometry. Ray optics deals with the simple properties of light, what we have listed above, the first four properties, and optical instruments, assuming that the light always travels in straight line. So in this particular chapter we will be studying number of optical instruments like a simple microscope, compound microscope, and telescope. Wave optics. The properties of light like interference of light, diffraction of light, and polarization of light can be explained on the basis of a wave nature of light. So wave optics deals with the wave nature of light and interaction of a light with matter. The third one is a photometry, which deals with the measurement of light, such as luminous intensity measured in a candela, luminous flux measured in unit lumen, and illuminance, which is measured in unit called lux. So many of you have seen the 60 watt bulb, 100 watt bulb. The amount of energy, light energy given out by the 60 watt bulb, 60 watt or 60 candela, that is luminous intensity. Rate of flow of energy is termed as luminous flux measured in lumen. The light from the bulb which is made to fall on the wall the brightness of the wall increases, that is called illuminance. So the brightness of the wall depends upon the distance between the bulb and the screen. More the distance, less the illumination, less the distance, more the illuminance. So illuminance is measured in unit called lux. So this third part, that is photometry, is not there for the syllabus. Further, optics is a branch of physics which deals with the nature of light, sources of light, propagation of light, properties of light, and effects of light. In regard to the nature of light, light has both the nature, particle nature and wave nature. So in regard to the nature of light, number of theories were proposed, namely Newton's corpuscular theory, Christian Huygens mechanical wave theory, Clerk Maxwell's electromagnetic wave theory, and Max Planck's quantum theory. Sources of light. So in high schools you have learned that the types of sources of light, namely natural and artificial. Sun is a natural source of light, whereas moon is an artificial source of light. Sources of light also are of these types: point source, linear source, or extended source. Third one, monochromatic source of light or polychromatic source of light. Monochromatic means single colored light is monochromatic, many colored light is polychromatic. Propagation of light. Light travels with different speeds in a different media. Different colors of light travel with different speeds in a media other than air. In a given medium other than air or vacuum, red travels faster, whereas violet color light travels slower. Properties of light. Already we have listed 8 properties of light. So all these properties of light we are studying under the heads of optics. Effects of light. Why sky appears blue in color, or sky appears blue in color? Because of light. Sun and moon appear red near the horizon. Soap bubble appears colorful. Compact disc appears colorful when it is orientation of the disc is changed. Oil film or the grease spilled in water appear colorful during rainy season. A coin in a water bucket appears to be raised. A stick immersed in a water trough appears to be bent. So these are the examples for the various effects of light. Optical medium. The medium comprising with or without matter, allowing a major portion of light to pass through them, is called optical medium. The types of optical media are homogeneous optical medium, heterogeneous optical medium, isotropic optical medium, anisotropic optical medium. Homogeneous optical medium. If the optical density of the medium is uniform throughout the medium, then the medium is said to be homogeneous optical medium. If the optical density of the medium is different at different regions, the medium is said to be heterogeneous optical medium. In continuation with the first video, further we discuss the optical medium. We have discussed the various effects of light. Thereby we continue with the optical medium. The medium comprising with or without matter, allowing a major portion of a light to pass through them, is called optical medium. Vacuum is an optical medium of lowest optical density, in which all electromagnetic radiations and all colors of light, even the visible light, travel with the same speed. The types of optical media. Number 1. Homogeneous optical medium. The medium is said to be homogeneous optical medium if the optical density of the medium is uniform throughout the medium. For example, vacuum, air, water, glass. Second one, heterogeneous optical medium. The medium is said to be heterogeneous optical medium if the optical density of the medium is not uniform, which varies from region to region, is called heterogeneous optical medium. Examples for heterogeneous optical medium: colloidal solutions. The third one, isotropic optical medium. The medium in which light travels with the same speed in all possible directions, then the medium is said to be isotropic optical medium. Example, the same: air, water, vacuum, glass, diamond, some oils. So in these media, the speed of light is the same in all possible directions. Fourth one, anisotropic optical medium. The medium in which the light travels with different speeds in different directions, then the medium is said to be anisotropic. Examples for anisotropic optical media: some crystals, quartz. In these materials, light travels with different speeds in different directions. So air, water, vacuum, glass, all these media are homogeneous as well as isotropic optical medium. In this particular chapter, ray optics, we consider only the homogeneous and isotropic optical medium, namely vacuum, air, water, glass, etc. Detailed study of properties of light. We have listed nearly 8 properties of light. All these properties of light we need to discuss in detail. Some properties of light can be explained on the basis of a particle nature of light, and other properties can be explained on the basis of wave nature of light. So the first property of light, that is rectilinear propagation of light. In a given medium, say vacuum, or air or water or glass. The light always travels in straight line, provided the size of the opening through which light travels must be too large compared to the wavelength of light. Suppose if consider a small hole, the size of the hole is too small compared to the wavelength of light, then light passing through that hole bends. Provided if the hole is large enough, then the light travels along straight line. Second property of light, that is a reflection of light. If you throw a ball against the wall, it bounces back. Likewise, the light particles falling on an object bounces back into the same medium with the same speed. The bouncing back of light from the objects into the same medium with the same speed is called a reflection of light. The reflection of light takes place following the laws of reflection, whether the reflecting surface is plane surface or curved surface. The ray diagram to study the laws of reflection. Let us consider a plane mirror MOM dash. The lower side of the plane mirror is silvered and painted. The upper surface of the mirror is a reflecting plane surface. So let us consider a plane mirror MOM dash. A ray of light AO incident obliquely on the plane mirror at a point of incidence O. After reflection, the reflected light travels along OB. ON is the normal drawn through the point of incidence. The angle between the incident ray and the normal is called angle of incidence. The angle between the reflected ray and normal is called angle of reflection. Whenever the reflection of light takes place at any surface, it takes place following the two laws of reflection. The first law of reflection is the incident ray AO, the reflected ray OB, and the normal drawn ON at the point of incidence O all lie in the same plane. If the mirror is in horizontal plane, then these AO, ON, OB, they all lie in the same vertical plane. The second law of reflection. The angle of incidence I is always equal to the angle of reflection R. If a light incidents obliquely at an angle I equals to 30 degree, then angle of reflection is also 30 degree. If a light incidents normally, along NO, then after reflection, light retraces its original path but in opposite direction. In that case, angle of incidence, that is for normal incidence, angle of incidence is 0, angle of reflection is also 0. So whenever the light incidents normally on the mirror, after reflection it retraces its original path but in opposite direction, is called as principle of reversibility of light. So we all know, whenever we brush our teeth standing in front with the right hand in front of a plane mirror, household plane mirror, in the mirror we see our image and it appears brushing with left hand. If you move away from the mirror, the image also moves away from the mirror. If you move towards the mirror, image also moves towards the mirror. If object moves towards mirror through some speed, with some speed, the image also runs towards the mirror with the same speed. These are the various properties of images formed in the plane mirror. So in detail we discuss in the next video the various properties of images formed in the plane mirror. Thank you.